So what we want to get at is why do we get a certain answer with division? There's got to be a reason behind it. So anybody want to take a stab at what they think division means, Matt?
I wrote separation of groups, specifically numbers, population, species, etc. Like in your example there, 12 divided by 4 is separate 4 into 3 groups of 4.
So make groups of 4 in this case.
Yeah, so you could apply whatever labels you want to that problem. Like it could be 3 groups of 4 if they were like kinds of animals that you need to separate, or like if you're separating people by the colors they're wearing.
Okay. I used to coach kids soccer, and often I'd split the kids up into groups, and sometimes for an activity, a group had to be a certain size to do the right thing. So it could be we have a special game we want to play, and it's got to be groups of 4 kids at a time. So this could be an example of that. I have 12 kids. They're going to do a pass the ball in a grid. Each group has to have 4 students. How many groups of 4 can we make? Right. Good. Anybody else have a different opinion on division? Okay, so equal is important. Yes. Okay. What else?
But a set number of groups from a larger number.
A set number of groups, that which is different than we have here. Yeah, totally. So a set number of groups. So instead of making groups of 4, it could be we need 4 groups. Then we would want to know how many are in each group. Good. And these are 2 totally physically different situations. Now, equal groups is important in both of these scenarios. I just want to draw this out. In the first one, starting with 12, I need to make groups of 4. So 1, 2, 3, 4. There's one group of 4. 5, 6, 7, 8. There's another group of 4. 9, 10, 11, 12. There's another group of 4. So the answer is 3 because we can make 3 groups of 4. Down here, I have to have 4 groups. And so then in this case, I'm going to do the physical act a little bit different. I'm going to start saying, okay, 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I end up with a very different picture. 4 groups of 3 instead of 3 groups of 4. Both are division, but just 2 different reasons, physical reasons we do division. This top one is often called the subtractive method for division. And sometimes it's called, it's supposed to be an or, the measurement version of subtraction. Because we're using 4 to measure how big 12 is. And this other one down here, we would call the sharing version of division. Sometimes it's called the partition or partitive. You want to break 12 up into 4 equal parts. How big is each part? Or we have 4 people we need to share something with. How many does each person get? We have 2 physically different ways to demonstrate what division means. Sharing or grouping. So for example, coming back to this subtractive one, I could say 12 divided by 4 means how many groups of 4 are in 12. Now, physically, this often leads to an array version of the answer. And remember, array is just a grid of things, like a rectangle. So I'm going to draw it just a little bit different. So I would draw my first group of 4. And then I want to keep building groups of 4 until I get to where I need to go. All right, so here we have that rectangular structure of an array. So often the array method is used for that groups of.
Question.
Yeah.
The next slide back.
Yeah.
So you grouped them going left, right, and then you grouped them from top to bottom.
Yeah.
But they're named something different. How am I gonna know that when I look at it?
So the orientation of my drawing in this case, so it's not like before when we were doing the base and the height, the base goes on the bottom, the height goes up and down. In this case, I just need to group by 4 somehow. And so this first time I drew the groups horizontally.
Off of the 4 set.
So the bottom line is what I'm going off of here, oops, wrong button. This one, is I'm looking for groups of 4. So first I made this group of 4, then I made this group of 4, and then I made that group of 4. And it really doesn't matter whether I orient them this way or whether I go the other way. I could have said, here's a group of 4. Let's make another group of 4. And we keep making those groups of 4 until we can't anymore, given how much we have to work with, right? We have 12 to work with. Okay. So these would both satisfy that. And the key here is I'm looking for groups of 4 with this method. And this method, again, this is called either the measurement method or measurement model or subtractive. And the key is the number I'm dividing by here determines how big the group is.
You're presenting this to a class. Do you think it's better to relate it to subtraction by calling it the subtractive model? Do you think it's better to keep it separate by calling it a measurement?
So
Like I know
with the kids, I wouldn't really be worried about having them distinguish between calling it the measurement model or subtractive model. I just want them to feel what division means.
right, but I mean, like if you're drawing a diagram to like illustrate to your class,
Mm-hmm.
like, do you think it's beneficial to kind of relate it to subtraction? By saying like,
So like with kids, I wouldn't call this measurement and I wouldn't call it subtraction. I would call this groups in. Whoa, how'd that happen? Oh, Brianna somehow gave me a check there. That was cool. Thank you, Brianna. Freaked me out there. Groups, I would call this the groups in model because we're looking for how many groups of 4 are in 12. So that's kind of, in my opinion, a better name to call it for kids. And the measurement or subtractive model, that's for us adults to give it a
right,
more scientific name, yeah, than groups in, right? But I would prefer to call this the groups in model because I'm trying to figure out how many groups of 4 are in 12. And as far as the subtraction goes, as I'm doing this, once I take a group of 4 out, I have 8 left. So this is literally, I'm thinking subtraction as I do this. Because I had 12, I put down 4 of them, that left me 8, now I got to divvy up the 8. So then I have 8, I put 4 more down, I have 4 left. Finally, from that 4, I can put them down, I can take them out of what I started with, and I have nothing left, and I can see that there's 1, 2, 3 times I can subtract.
Okay.
And some people consider this repeated subtraction a different model than the physical picture. And in a sense, it is. So we could consider this another model, the repeated subtraction model. So we have the physical version, which I like to call groups in. And then the version where we actually show subtraction and count how many times we subtract. So if we go back a moment and we say this is our first division model and the sharing is our second division model, we now have a third division model, which could be repeated subtraction.
Okay.
And some people say, no, it's the same. Other people say, no, it's really, you're writing down something different, so it's different. I tend to think it feels different to me, even though it's related.
The groups in method feels more like addition than it does subtraction.
Yeah, we're adding up 4s till we get 12. And we had that idea with subtraction, like what do I add to subtract? So there is definitely that relationship, for sure. Another model is called, we'll call this a fourth model, the missing factor model. Or we could say the what do I multiply by model. So with this, I would do something like 12 divided by 4 equals what? And sometimes my what is a question mark, sometimes it's an empty box. And we just rewrite it as multiplication. So going backwards, I would say, what do I multiply by 4 to get 12? And a lot of kids are pretty good at identifying, remembering their multiplication facts, or just counting up 4s to come up with an answer. And some kids might have to do something like, well, let's see, 1 times 4 is 4. Nope. 2 times 4 is 8. Not there yet. 3 times 4 is 12. Bingo. I got it. So it could be this kind of repetitive algorithm to come up with an answer.
Not like a guess and check.
It is a guess and check, and we do it in order. And it turns out there's a related thing to this. There is a thing called the division algorithm. Which I wouldn't go over with kids, but I'm going to go over with you guys. And what the division algorithm says is for something like A divided by B, there exists a number called Q and R, where A equals B times Q plus R. And R is less than B. We'll unpack that in a second. And this is what's called the division algorithm. Now, I did an example of it right here, kind of sneakily, where the remainder R is 0. And I'm going to write it down in a slightly different way. And again, this is division algorithm for whole numbers. I should be a little more specific. And it's a matter of, can we come up with Q and R? Anybody have an idea what Q stands for in division?
Remainder.
Quotient. R would be remainder. Yeah, so quotient is the result of division, and R is anything left over. So far, we've had a 0 left over. Let's take a slightly different problem, slightly harder, but not too bad. Let's look at 17 divided by 4, which we could also write as 17 divided by 4, or 17 divided by 4. We have several ways to show division.
What was the last part of the formula? Or less than,
R has to be less than B. So what I want to do is I want to build 17 with multiples of 4 if possible. And so we can call it an algorithm by just stepping through one at a time. So I could say 17 is 1 times 4. And then I would need to add on, in this case, 13. And the problem with this right here is this is my R, it's not less than 4. So we just keep going. Okay, what about 17 as 2 4s? So that would give me 8, so there'd be a remainder of 9. What about 17 as 3 groups of 4? That would be 12, we're getting closer. Remainder is 5. Okay, what about 17 as 4 groups of 4? Then we would have a remainder of 1. And finally, we have the R is less than B, right? 1 is less than 4. And we got an answer. So an organized guess and check. So then we could say something like 17 divided by 4 is equal to 4 with a remainder of 1. And for a while, we note the quotient and the remainder. And eventually, once kids get into the idea of fractions, that would be 4 and 1/4. This is later.
why is it some math symbols have several different ways of being represented and others don't?
That's a good question. So like we have a bunch of ways to write division, but there's only one way we write addition. There's a few different ways we write down multiplication, like an X or a dot or the asterisk sometimes. Why? It's a big world. And different places, people just chose to write it down different. Maybe one person thought they had a better idea than someone else's, and it caught on in some parts of the world, but not others. Good question.